Right, we good to go? Yeah, I believe. Oh, hi. Okay, let me know. Highly available Keycloak, identity and access management with multi-site deployments in the cloud. Welcome to our talk here at Devoxx France. My name is Alexander Schwartz. I'm a principal software engineer at Red Hat, working full-time on the Keycloak project.
And my name is Ryan Emerson. I'm also a principal software engineer working on the Keycloak project.
Right, and we have some Keycloak news and history for you. But let's first clarify, what is an identity and access management system, and do I need one? I think you need one, otherwise I wouldn't be here. So it's about authenticating and authorizing your users for your services. Your users have mobile devices, they have laptops, they have their browsers, and they need to log in order to access your services. And they log in using maybe username and password, maybe they have other credentials, maybe they have a second factor. And all this is handled by Keycloak. And after they've been logged in, they have a token, being it an OpenID Connect token or a SAML token, depending on the services they want to access. And with these tokens, they send it to the services, and the services can verify the token that is still valid, who the user is, and then use it also for authorizing the users if they have the right permission. And Keycloak is all that, right? It's authentication, authorization. You can manage your users, add users, remove users, giving them new credentials, permissions. You can handle user registration in there, password resets. You can integrate it with your existing infrastructure. That's what an identity and access management system does, and that's why you need one. So when you start with Keycloak on day one, it's just single sign-on. It's cool, and users need to remember only a single password, right? To log into all their applications. They authenticate once a day during the morning, and then the rest of the day they use many applications. They switch between applications, but they don't need to log in again. You then want to make things more secure. You add a second factor. And then, you're even better than before. And to make your users feel at home, you add your company logo to the login screen. So you theme it, and then, it really matches your company, and it's great. And I think with all these features, for the day one features I call them, it makes sense to use Keycloak even for a single application, because it takes away all this hassle about managing users, having all this functionality there, and getting that functionality right. And this is what users then usually see when they start using Keycloak for the first time. They have a login screen, they put in username and password, they put in, and then they are signing in and done. On day two, you want to be more flexible in your setup. You want to use more of Keycloak features, and for example, you want to integrate with an existing LDAP or an existing Kerberos that you have in your organization. So the user information is already there. Let's use it using Keycloak. Or you have an existing SAML service and your applications want to talk OpenID Connect, then Keycloak is the thing to use. We do the brokerage for you. If you have an existing OpenID Connect and your applications want to talk SAML, then you can also use Keycloak. Or if this OpenID Connect service creates tokens, but these tokens are not the fit for your applications, you want to have other information there, additional information in your tokens, use Keycloak. Even if you say you have your user information stored in a very custom, grown in your enterprise user database, maybe for your customers, where they register, where they have all the information, you can connect that to Keycloak using a custom user store, and then those information can be used in Keycloak. And I say day two is about using all your existing user information wherever it is in your Keycloak and your authentication flows. When you connect Keycloak to LDAP, the login screen is the same as before. You have a username and password, but the credentials will then be checked against LDAP. If you choose to have brokerage with existing providers, one possibility is to have some buttons where you click on Let's log in using GitHub or Stack Overflow or whatnot. If you choose to have Kerberos integration, users will not see Keycloak anymore because the login screen will be gone. They don't need to log in. If for whatever reason that one machine does not have Kerberos, Keycloak will automatically fall back to username and password, and you're putting that in. Day 3 is then about eliminating churn. So user password recovery. Even if you store your users in LDAP, Keycloak can do the recovery flow, send out an email with a link, people click on it, and do all the password reset. That works. You can have user self-registration, so Keycloak presents a screen where people can fill in the data that you need. It even got better in Keycloak 24. With declarative user profiles, you really can customize that screen for user self-registration and user self-data management. So when they move to a new address, they can put in a new address. All that is then there. And this resolves a lot of calls and tickets for both your IT department and your call centers. And this is how it looks like. You switch a toggle, and you have some more links on your login screen. You have a forgot password link there, and a register user link. So now Keycloak is a critical component in your infrastructure. So what to do now? So you want to have it running 24/7. You want to do upgrades, possibly during the day, seamlessly. So you want to reconfigure a node and reboot it, and don't lose any user sessions, and users should still be able to log in. If you might be legally required to have 2 data centers communicating with each other to have a highly availability setup. So yeah, that's the next section of the talk. And Ryan, let's tell us how that works.
Okay, thank you very much, Alex. So in order to understand how we get to highly available Keycloak architectures, we first need to understand some of the concerns Keycloak has around managing data in the more basic architectures. So I'll just start by explaining a very simple Keycloak setup. So here we have a single process. This single process is responsible for handling all user requests. And we want session data to do with the login to be as performant as possible. So what we do is we actually store the data in memory using a InfiniSpan embedded cache. Then we have some data that's not so frequently updated, such as users, groups, roles, and we persist this state using a traditional database. Now this configuration, it's fine for dev environments, proof of concepts. However, it leaves a lot to the imagination when it comes to production. For example, you can only vertically scale this solution. You can throw resources at the single process, but you can only do that for so long. And there's no resiliency here. If the Keycloak process goes down, then your workflow is completely disrupted, nobody can log in. And even worse, because we store data in session data in memory, if the process then restarts, all of your users have lost their sessions and they have to re-log in. So typically what we see in production is what I'm going to refer to here as the N-Keycloak processes model. In this diagram, hopefully you can see we have 2 Keycloak processes, but this could be 2, 5, 10. This architecture horizontally scales quite well. So the idea is that we're increasing performance because you now have multiple processes able to handle the user requests, and you're increasing resilience because if one process goes down, another one can take over. However, this architecture isn't without its own challenges. Now we need to ensure that the in-memory session data is accessible to all of the Keycloak processes, and we need to make sure that there's multiple copies of this in-memory data to tolerate processes failing. So to solve this problem, we again leverage InfiniSpan for caching, and we leverage its distributed caching mode. So we will guarantee that every session is replicated at least twice, and if it's not hosted on one Keycloak process, that Keycloak process will be able to remotely fetch it from one of the processes that does host it. So this is 2024, so obviously it has to have Kubernetes involved. People typically deploy this, and assuming they've configured their Kubernetes configuration sensibly, this architecture will be able to tolerate pod failures and Kubernetes node failures because you would have the pods hopefully distributed across multiple Kubernetes nodes. However, there is still a fundamental flaw here. You are at the whims of a cloud vendor's availability zones. if the cloud vendor's availability zone goes down, you lose your entire Kubernetes cluster, and again, you have no uptime. Keycloak users can't proceed with their workflow. So we now need a solution that can tolerate such failures, and as good as Amazon, Azure are, etc., they do happen. So our approach to solving this, you're probably going to guess where I'm going to go, is we simply add another availability zone into the mix. So we now have multiple sites with Keycloak deployed, and I say simply add another availability zone to the mix. Unfortunately, it's not simple. It actually causes as many problems as it fixes in a way. Now we have to think, okay, we have our 2 sites. How do we ensure that the session data is accessible and consistent between the 2 sites? And also, how do we ensure that persistent state is accessible and performant for both of the sites that are accessing the data? So we actually start by simplifying the model, and the way that we do that is we designate one site as active and the other site as passive. And what does this mean? Basically, the active site is now responsible for handling all user requests, whereas the passive site is there entirely for redundancy purposes. So this greatly simplifies our write semantics, because if you think of the flow of data, data is effectively now having to just trickle down from the active site to the passive site. This avoids data contention because data flows one way. Whereas if we had some kind of active-active model where both sites were able to leverage user requests, then we would have issues where, for example, with the session data, you could have both sites trying to update a key value, or in terms of the persistent state, trying to update the same row in the database. So the idea here is that if the active site goes down, we have the passive purely there for redundancy. The formerly passive site now becomes active, and once this is ready, Keycloak users have availability again of their service, and they can proceed as before. So from a user perspective, does this complicate things? As a Keycloak user, do you have to be concerned about which site do you communicate with? Luckily, the answer is no. We didn't think that would be acceptable. So what we do is we leverage Amazon's Route 53 DNS service. Luckily for us, the Route 53 service has a built-in active passive failover capability. So the idea is that all users now connect to a Route 53 DNS hostname. Route 53 then determines which of our 2 sites is the active. How it does this is based upon our initial Route 53 configuration, so it is under our control. And Route 53 ensures that requests always get routed to the active site when it's available, as we expect. So what Route 53 does to determine whether a site is healthy is it periodically executes some health checks, and if the health check for the active site goes down, then the DNS records are updated, and all subsequent user requests are then forwarded to what was the passive cluster, but is now the new active, AZ2 in this case. In general, we find this approach works very well. However, because it is a DNS-based solution, there is one kind of fundamental limitation, which is that clients can cache the DNS resolution, which can lead to longer failover times if the cache isn't invalidated. However, in our experience, ensuring the clients are correctly configured mitigates these issues, and it does work well. But it's just one thing to be aware of with such a solution. So now we have our active and our passive site. We have our users correctly having their requests forwarded to the active. How do we handle the session data? This is one of the tricky parts. So again, we're using Infinispan, and up until now I've just said Infinispan and hoped you know what it is, but I'll briefly touch on what Infinispan actually is. So Infinispan is a in-memory key value cache. It has very advanced clustering capabilities. It is an independent project. Keycloak leverages it a lot, but you can use it with your own applications as well. It has a very mature Kubernetes operator for deploying itself, as well as integrations with Spring Boot, Quarkus, and other third-party frameworks. Unlike some other popular caching solutions out there that's been in the news recently for license issues, it's Apache 2 licensed, and it won't change. That's always going to be the case, and we're proud of it. So back to Keycloak. Previously, I was saying we were using embedded InfiniSpan. What this is where the InfiniSpan process exists within your JVM application, whereas InfiniSpan also offers what we call client-server mode. And the difference here is the InfiniSpan server is completely independent from your application, and your application accesses the cache remotely. And this can be done using the Redis protocol, HTTP, or InfiniSpan's own Hot Rod protocol. And why am I going into such detail here? Well, hopefully it'll become apparent on these slides. So when we are talking about replicating session between sites, we now have InfiniSpan server deployed in our architecture. There's no session data deployed in Keycloak itself. And the reason we do this is we leverage InfiniSpan's cross-site replication abilities. And what this does is when a Keycloak pod requests a write to session data to the InfiniSpan server, the InfiniSpan server synchronously replicates this write to the passive site, and only when this completes does the InfiniSpan server return to the Keycloak pod, which in turn returns a response to the Keycloak user. And the reason this is important is when the Keycloak user gets a response, they can be safe and assured that their data is replicated on both the active and the passive site. So if the active site goes down, their session data is safe. And so we need the InfiniSpan server because it provides much more advanced capabilities around this cross-site feature, which is important for DevOps or your SRE teams for managing this in a production environment. As a secondary benefit of moving towards the InfiniSpan server, the Keycloak pods no longer store session data, so they can now be scaled up, scaled down, completely restarted, killed, without losing any session data, as long as the InfiniSpan server pods remain active. So we now have our two sites. We have sessions being replicated as expected, user requests going where they should be. We now need to talk about the database. Previously, if you're having a single site, you would probably deploy the database in the same Kubernetes cluster as your Keycloak pods. However, that's no longer possible because if that availability zone goes down, you lose your database. And if the database goes down, Keycloak can't proceed. So how do we solve this problem? Well, again, Amazon provides a nice service for us. They have the Aurora database. We utilize the Postgres flavor of this in particular. But Aurora is designed with multiple availability zone architectures in mind. And I'll just quickly give an overview, very high-level overview of how this works and what it provides for us. So hopefully you can see here we have our Keycloak pods on the left-hand side. This is the pods on both our active and our passive site. They connect to an Aurora load balancer. This Aurora load balancer then forwards all read and write requests to what Aurora deems their writer instance. This writer instance is hosted in the same availability zone as our active site. This is for performance reasons. We want the lower latency as possible. But the interesting thing about Aurora is when we perform a write operation, the writer instance ensures that not only is a data copy written to availability zone 1, but it's also written to availability zone 2. This all happens synchronously, so when the write completes, Keycloak gets a response. We know that our data is replicated on both availability zones. So the idea here is that when availability zone 1 goes down, Aurora transparently elects a new writer instance on availability zone 2, and our Keycloak deployments can continue to function as expected from availability zone 2. The failover of a writer instance from one AZ to another takes approximately 1 minute in our experience. During this minute, we do have downtime with Keycloak, but I'm sure you can appreciate 1 minute is much faster than the amount of time it would take to redeploy this entire stack on a fresh availability zone. We're talking hours potentially there. The really nice thing about this solution is the only change we had to make to our Keycloak deployments was that we now have to utilize the AWS JDBC wrapper. And the reason for this is this driver is actually aware of Aurora failovers. So when we fail from AZ1 to AZ2, any connections left in the Keycloak connection pool on the passive site are invalidated, and we can then guarantee that all future database operations are executed against the availability zone 2 that is alive and kicking. Beyond that, there were no changes required to Keycloak semantics, so integration was very straightforward in that sense, which is nice. And here, one too far. Here's just a diagram to summarize what I was saying before. We have our active and passive site. All of the Keycloak pods are now communicated with the Aurora load balancer. So I've introduced a lot of different things there. Hopefully you've followed 90% of it at least. But just to summarize, I'll give an overview of the entire architecture and how everything fits together. So on the left-hand side here, we have our people, our Keycloak users. They now exclusively connect to Keycloak using a Route 53 DNS record. Route 53 is responsible for forwarding all of the requests to our active site, which in this case is availability zone 1. Within this availability zone, we have our Kubernetes cluster, our Keycloak pods, InfiniSpan server pods, and we also have our Aurora writer instance in the same AZ with the Keycloak pods connecting to it. Then, for redundancy, we introduce our second availability zone. This has the exact same stack as the first availability zone. However, the secret sauce is that we have InfiniSpan server performing cross-site replication to ensure that session data is consistent between the two sites. And similarly, we have Aurora ensuring that our persistent state is also consistent and available in the event of failover from availability zone 1 to availability zone 2. So I'm sure you can appreciate this architecture didn't happen overnight. It was the result of a lot of discussions and investigations by the Keycloak team. I'm now going to hand over to Alex, who will talk you through some of our experiences, and hopefully you can gain some insights when it comes to your own high availability journey. Thank you.
Yeah, and one more thing we should mention, like all this thing we're presenting here is part of Keycloak 24 that has been released some weeks ago. We also publish documentation that goes with it and explains, well, how Keycloak works in this environment and how you can exchange the different AWS components we're showing here with your own infrastructure components of your choice, as long as they match the criteria we outlined in the documentation. Right, so this architecture we see before, well, we put it on a lot of stress to figure out where it fails and how it fails, and then to improve it. And we had some interesting, I'd say, and surprising system behaviors under load. And I walk you through some of those to, well, maybe your applications will suffer from same behaviors, and maybe you want to adapt one or two solutions that we tried out. For example, overload situations. We tried a lot of overload situations with Keycloak here, and we found out they require load shedding, which is now part of Keycloak 24. So what defines an overload situation? It is more requests coming into the system that can be handled. And when something like this happens, you will observe that requests queue up, you will have a lot of memory usage, your client requests will time out, users will also see timeouts in their browser. and things are going bad, right? And the remedy is to drop those excessive requests as early as possible to provide like at least a defined response to the clients. A timeout is basically the worst thing you can give to a client. Better is then you give it an early reply saying, oh, I can't handle this at the moment, so we are replying with a 503. And what we implemented then, as a first implementation, that's part of Keycloak 24, we have implemented a queue length that you can configure. If the queue length is already at its maximum, we respond with a 503 response immediately, and if the queue is not full yet, we unqueue the request. So imagining you have a system that you know can handle like 1,000 requests, 200 requests per second, and you configure the queue with around 1,000 requests, you can be, you can estimate, okay, no requests will be in the queue for more than 5 seconds, and yeah, all the other excessive requests will get a response immediately with 503 and without bringing our system to the edge of collapse. There's also a cache stampede. We found that was happening under load. So when you have stressing the system with a lot of logins per second and refreshes and users doing their things, and you then start restarting pods, restarting them because there's maybe a failure in a node, or you want to restart your pods because you reconfigured something, and then this should be seamless, but there's then a cache stampede happening. So you have just a single pod, maybe multiple pods, and they are getting, once they're starting up, they're getting a lot of requests at the same time. And what they do then, their caches are empty. They try to get the same data from the database all at once. So you basically run out of database connections. Everybody is trying to do the same thing on the database, which is both a waste and will use a lot of resources and might get the system again on the edge of a collapse. Yeah, you might see timeouts, maybe timeout waiting for a database connection, timeouts at the client side. And the remedy is to do some locking. Well, locking sounds scary, but it's still the right thing to do. So all the requests will check if there's already an existing running request fetching the same data this new request is also waiting for. And then instead of doing the same task the other thread is already doing, we then wait for this to complete. So again, small chart here. So when there's a pending request for the same resource, we'll block and wait for the other request to return. If there's no existing request, we go and fetch it from the database. And that really improved the behavior of Keycloak when you restart pods under high load. We also found, well, as Ryan said earlier, we're running on Kubernetes a lot. We suffered from blocking probes and blocking metrics. So the thing is, you put your system on a lot of stress, and then you see some scary events in your Kubernetes event log telling us liveness probe failed so many times, and eventually container failed liveness probe will be restarted, right? And restarting pods under a high load are a bad thing. So let's do something against it. Again, we have too many requests coming in. We already have our load shedding in place. So we want to shed the load, but probably not our liveness probe, because that will keep the pod alive. But in our first versions, we had those probes were blocking. They were maybe waiting for a database or maybe waiting for other requests in the queue. And the pods would then restart. Also, the metrics are blocking, which was bad. So yeah, we talked to the nice people at the Quarkus team and asked, well, we want to have non-blocking probes as part of Quarkus. And that's what we got. So we now have non-blocking probes. So all the requests going, HTTP requests for the liveness probe will still be answered, even though all the other blocking requests that we have will be load shedded. Still, we have the situation where we might miss out on some metrics under high load. That's something we hope to fix in another release soon. So we were working on that over several weeks and months, and some of the, I'd say, habits that helped us to get where we are now, I want to share them with you. Well, we kept some up-to-date documentation. So we used a static site publisher called Antora. I gave a talk about Antora yesterday evening, so you might be able to rewatch that as a recording if you don't know Antora yet. So this helped us both within the team when we were running our different tools. It helped us in onboarding new team members, and it also helped the community because this documentation is published together with the project, and people were trying out our different modules. They were trying out our data generation. They were trying out our load drivers. They are trying out our deployment scripts. So yeah, and all that is, all the documentation that comes along with that script is in the public, and the static site publisher helped us with this. We used a lot of ephemeral environments, and we had a rule: you can have as many environments as you want, as long as they're automatically deleted at the end of the day. So if a developer said, yes, today I don't want to use this shared environment because I want to do a very heavy load test, they could press a button and spin up their own environment. And we had the automation in place to not only build this environment, but also fully destroy it at the end of the day. And this helped a lot and allowed us to do the experiments we needed to get to the solution that we are showing you today. Well, we did a lot of testing, and it was, well, measure, record, and repeat. So we had these ephemeral environments, and in these ephemeral environments, the first thing we added was collection of metrics, searchable logs as early as possible, but these are the things that help you to really find root causes. Something that was a bit tricky for us, and we did several experiments here, is how to capture insights after a run if it's an ephemeral environment, because the environment will be gone, the logs will be gone if we don't do anything around it, the metrics will be gone, the traces will be gone. So yeah, we did some automation around this, for example, to capture snapshots of Grafana dashboards from an ephemeral environment before we tear it down. After the run, so it's there after we tear it down, but together with the run that we did. We also have an IT run for performance and functional tests that will help us to spot regressions. So every night we build up 2 OpenShift clusters, deploy Keycloak, run functional tests, run load tests, and have then graphs that track our response times and load times from day to day over the last month. The tools that I found most helpful in this setup is the Java Profiler. Especially looking at such flame graphs shows us where we spend the time, where things are blocking. In the early days, I also tried to do async profiling in containers and found it was not working until I figured out I probably should have used wall clock async profiling in my containers, and that works even in OpenShift with all the security lockdown, which is really great. Collecting these flight recorder statistics, we found a project from some fellow Red Hatters called Cryos.io. So if you configure your containers running in Kubernetes the right way, it can connect to your Cryos.io will connect to your containers running in OpenShift, and you can then either do it via APIs calls or automation, or by clicking on a button, get flight recorder recordings in the UI, download them, and won't need to do the hassle of how to get this started and stopped in my cloud environment. So that's a really, really cool tool. OpenTelemetry, Java Agent, is also a nice piece of technology. It provides you with metrics, with traces, and also logs. Keycloak does not have yet fully OpenTelemetry support, so we were starting with using the agent, although the Quarkus people recommend to use the Quarkus built-in instrumentation for OpenTelemetry. It works reasonably well, I'd say. We hope to have full built-in OpenTelemetry support soon, but that helps a lot to get the metrics that we needed. GitHub Actions is also our friend, both in terms of automation and also when doing things in the public. As an open source project, we did a lot of the nightly CI testing. We were recording the results here, setting up environments, and then there's one feature there called Workflow Dispatch that you can trigger a workflow by clicking in the UI or running something on a command line, and then kick off, for example, setting up a full environment using a GitHub workflow. Gatling was our tool to drive the load. So we're Java developers, and well, we can do a little bit of Scala. And so we picked Gatling as a tool here for load drivers. Running it on a local development machine is usually fine, and if you run it against localhost, everything is usually also fine. Once you start running it over a network to your load testing targets, you will find out that, I don't know, maybe at 250 connections per second, running it against a single target, maybe at 300 or 500, you will find that you're congesting the network stack of your machine, and you need to scale horizontally with multiple nodes. We will have that setup available. If you go to the link below, we have a setup where you can spin up several EC2 instances, run Gatling there, retrieve the results, and generate one consolidated report from all the load drivers you ran on the different nodes. Well, Kubernetes for scheduling deployments, like we're using operators a lot here, the operator for Infinispan, the operator for Keycloak, the operators for Cryostat, the operators for whatnot. And I think the most helpful command is then kubectl wait for condition. So I think a well-behaved operator should have some good conditions to wait for to figure out when it's done with its work. Yeah, we used the Red Hat OpenShift service on AWS, or ROSA for short, to create our ephemeral environments. And then it came up with, well, they're now starting up a lot faster with host control planes. They have like built-in, I say cartridges, but that's maybe an old term anyway. For you add then the logging, the metrics, and whatnot add-ons you want to have afterwards in an automated way. And then we have our ephemeral environment set up. Grafana for interactive dashboards. I'm a very big fan of the Grafana dashboards. We create them as a team, store them in Git as JSON, and deploy them also to our ephemeral environments. I think the diagrams I like most are histograms plot histograms as heat maps over time. So for example, you see here the clock time on the lower axis, and on the left axis you have the histograms of response times, and you see how that latency spreads, and that's one of our future tasks to reduce the tail latencies we currently see with Keycloak in some cases. And once you have everything set up nicely, you can really jump from metrics to traces to logs and back. Helm, we're using Helm for fast turnaround and deployments to do our experiments on a developer level. It has a simple templating language. We have our charts, but well, they've grown over time a bit or grown rapidly. They're good for development and performance testing. Unfortunately, you can't use these charts directly for production environments, but because they have just too many features. But we still provide blueprints on how to do things in production. The future roadmap of Keycloak, high availability in the cloud, or Keycloak in general, also is we have lots of ideas for enhancements. So we want to support active deployments and evaluate possible benefits. We want to simplify the deployment and upgrades. So you will have seen probably from Keycloak 23 to where it was a preview to Keycloak 24, where it was fully supported. We had lots of simplifications in the configuration, and we will continue that route. We're looking at other cloud databases and cloud vendors that we want to support in our blueprints. We want to also provide some hardened blueprints as well. Tonight there's going to be a Keycloak Birds of a Feather session at 8 o'clock. So the two of us will be there. We're happy to see lots of you there as well to discuss with you more future roadmap items, things you're currently doing with your Keycloak deployments, maybe brag about them, maybe share what's currently not working, and we can have a look how we can fit it on a roadmap. So really come to our session there at 8 o'clock and talk to us about Keycloak. The things we talked about today is about Keycloak with its own homepage. Keycloak Benchmark has its own sub-homepage. There's the Keycloak High Availability Guide, which has been updated a lot for Keycloak 24. So describing what Keycloak supports. These are the blueprints for AWS, but also the criteria how to do it in other non-AWS environments. There's the Keycloak book, 2nd edition. So the 2nd edition, the major upgrade there was going from the Wildfly setup to the Quarkus setup. So if you want to read up on that, that's a good source for that, or if you're new to Keycloak. There's also the homepage of Infinispan, so if you want to read up more what Infinispan can do in your setups, in your applications, how do you want to cluster it, how you make it highly available, that's all there is on the, with lots of documentation at the Infinispan homepage. These are the contact details from Ryan and me, so please get in touch with us. And yeah, we have now 4 minutes for questions. Thank you a lot. All right, some questions. Yeah, go ahead.
Hello, thank you very much for all these elements and the presentation. Please, can you tell us, you put in the roadmap the active-active high availability scenario. Why have you taken the active-passive first step and not go directly to the active-active scenario? Why are you making active-passive high availability and put in the roadmap the active-active and not directly go through active-active architecture?
Yeah, so we thought we thought active-passive would be simpler for us from a developer's perspective. We needed to fix a lot of things on the way, which now fixed, and now we feel ready with all these things already built into Keycloak to go to active-active. For example, this conflicts that might occur between 2 sides of Infinispan, right? That was one of the concerns.
Yeah, and we've fixed a lot of bugs along the way, and as a team, we've learned a lot of things, which is, I would say, better equipped us for the harder challenge of active-active. And you're saying there about potential data conflicts and things like Infinispan's cross-site capability. We're currently using the synchronous mode, which is good for active-passive. However, there is also a asynchronous mode, which is probably going to be more suitable for active-active. But that's a bigger change because Keycloak in the past had already been kind of used with this synchronous Infinispan mode, but asynchronous was a whole new environment. So it's all to do with experiences gained, really, and we're learning as we go. I think it's a safe comment.
And we need to pick an active-active database at some point. So with the setup, you've seen that the writer instance of Aurora is usually with the, well, it should be, for performance reasons, with the active side. If then the passive side would write to an active, to the writer instance of Aurora on the other side, you will have the latency there. So yeah, that's a handful, maybe 2 handful of reasons why we started with active-passive.
And for this persistent part, you are thinking to use UOperator, DB operator, or something like this, or make applicative usage?
Yeah, maybe talk about that later, maybe on a one-on-one. Let's see.
Thank you.
Okay. So the question was if we're supporting rolling upgrades. Yes, we're rolling updates of configuration. So as you're doing rolling upgrades with the same version of Keycloak, this is supported. At the moment, we don't officially support upgrades. So upgrading from one patch level to another or from one major version to another. This is on our roadmap as well, and for Keycloak 25, we are planning to have that you do upgrades, not rolling, but with restarts. But then we're working on persistent sessions, so in Keycloak 25, fingers crossed, your users will still be logged in after you perform the upgrade. Okay.
That's something I didn't quite get. It's mostly regarding Infinispan. Sure. How does it work? Is it purely synchronous, or does it work asynchronously too?
So in the active-passive scenario, we're using synchronous replication between the 2 sites, but Infinispan does have an asynchronous mode. And when you're replicating data asynchronously between the 2 sites, you can configure conflict strategies. So if there is ever a conflict on the active-active write, depending on your application's requirements, it can handle in either using one of our basic strategies or a custom one that you can write yourself.
Okay, so could I possibly have a scenario where I have some regional sites with Keycloak deployed in it, and Infinispan as a standalone server. And the size go up and down depending on the day. I mean, I can't know when, I can't know why. And can I manage, let's say on a central data center, all the client's configurations and push the sync when the sites go up? I mean, is it automatically down, or would I need to do something afterwards to make it work?
Well, as long as the Keycloak pod is there, at least one Keycloak pod is there to handle the request, and then that sends it to the Infinispan server. The Infinispan server should do the rest, if I understand the question correctly.
Okay. Well, maybe I'll talk to you.
Yeah, sure.
Thanks. And thanks a lot for the talk.
You're welcome.
Thanks very much for the talk. I'm wondering what the upper bound on throughput is.
Oh, well, we're over time. I just here.
Yeah.
Sorry.
So please come up to the front. We have some stickers here and postcards for Keycloak in the front row. Please pick some, and hopefully see some of you at the 8 o'clock.
Thank you.
Thank you.